Episode 23. Rule Your Pool Podcast. I'm your host, Eric Knight with Orenda, and with me, as the last two episodes have already had, Joe Swayze, our VP of Sales. Joe, thank you for being here.
Hey, glad to be here. Hey, everybody.
We're grateful, and this is going to be a shorter episode. It's a much more simpler concept. Much more simpler. Did I say that right?
Much more simpler. Didn't sound right.
We're going to roll with it. We could easily re-record this, but we're not going to. Because
we undermeant what you stood.
Yeah. We like to have fun here. And our brains are melted because it's springtime in the pool business. So anyway, this is pillar number 3, and it's about phosphate removal. The last two episodes, we covered pillar 1, which was LSI balance. Pillar 2, which was organic waste management, non-living organic waste management. And this is pillar number 3, keeping our phosphates to a minimum. So without further ado, episode 23, pillar 3, let's go. Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody, regardless of experience, can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go. Joe, why do we need to remove phosphates? Why are phosphates important?
Well, phosphates, it's been a buzzword for a while in the industry, and people are just honestly starting to understand that phosphates make it difficult for your chlorine to be efficient, and they make your life complicated when you've got too many of them.
Mm-hmm. Well, technically they're a food source for anything living in water, but algae is the biggest problem in outdoor pools that get associated with phosphates. And there's a lot of conflicting information online. I spoke to a homeowner this week that gets her information from a forum online. They say, phosphates don't matter. Well, we beg to differ, and we would not be putting our reputation behind it if we didn't have the science to back it up. You can get away and be fine managing your pool ignoring phosphates. It's possible. I'm not going to pretend that it's not. You're just going to spend a lot more chlorine doing it. And we happen to be in a major chlorine shortage. So, your call. What we want to talk about here is what phosphates actually are. We don't want to get necessarily too in the weeds, but I want to talk about where they come from, how they get in your pool, and then why it's so important to reduce those phosphate levels and why it, Joe says improve chlorine efficiency. Well, what does that actually mean? Because chlorine doesn't directly interact with phosphates, we've learned. And by the way, earlier, like years ago, 2017, I think, I wrote a blog based on a class that I took in a trade show. And in that trade show, the teacher who, I'm new to the industry, I don't know anything. I'm just soaking up this information, taking diligent notes. And he said in that class that phosphates bind to the hydrogen and they weaken chlorine by converting hypochlorous acid into hypochlorite ion. So I wrote that down. That's why, phosphates, they weaken chlorine directly. Oh boy, is that wrong. And I want you to know as listeners today, everything we are saying today is absolutely backed in science. We have been through the ringer on this topic to make sure that what we're providing to you today is real. It is fact-checked. It is verified. It is, even though this is sort of an ad-libbed episode, we've written enough information to know what is and isn't okay to say because we don't want to blur the lines at all of reality when it comes to phosphates. So, Joe, let's think about phosphates. Now, there's a lot of different types. Now, you've been in the testing industry for a long, long time. What do phosphate test kits measure?
Typically, phosphate test kits in our industry are measuring total phosphate. You can get phosphate test kits in the water quality industry, very complicated ones, or, in other spaces that are measuring specific types of phosphates like orthophosphate, right? So in our industry, we're measuring total phosphate, which is probably in most cases measuring just orthophosphate.
Mm-hmm. Well, that's because the vast majority of phosphates are going to be orthophosphate, but a lot of test kits only measure orthophosphate, right?
That is very true.
But there's a lot of different variations. So a phosphate is just a form of phosphorus that has stabilized itself sort of. I shouldn't say the word stabilized, but it's the most prevalent form of phosphorus, the element, that you're going to have in your water. And there's a lot of variations. There's condensed phosphates, there's polyphosphates, there's phosphonic acids, there's phosphoric acids, there's all sorts of combinations. There's organic phosphates, there's inorganic phosphates. Well, what we're dealing with in pools are inorganic phosphates. Okay? Organic phosphates, you don't have those in your pools. Okay? Those are in foods, those are separate. Now, we are going to make a full open disclosure here. Orenda does not make algicides. We do not make any algicidal claims. We do not kill algae with any of our products whatsoever. What we're talking about here is a nutrient. We can remove phosphates with PR 10,000 or even CV 700, and there are a lot of other great phosphate removers on the market. Okay, this is not a complicated thing to remove from your water, so keep that in mind. We are not saying we are going to get rid of your algae problem by removing phosphates, because that's not how it works. There's more to the story. Let me explain. When you have phosphate variations in your water, all of those can be converted, pretty much all of them can be converted into an orthophosphate with sunlight and an oxidizer present. So if you have a phosphoric acid or a polyphosphate or a sequestering agent of some kind, which are almost all phosphate based, if they're out in the sunlight long enough, they will convert into something that is a it is a testable orthophosphate. Right, Joe?
That is correct. Yep.
This segues into what I wanted to say of how do phosphates actually get into our water? And the first question is, where do you get your water from? Was it trucked in originally, and do you have a hose that fills it or an autofill? What is in the source water? That's the question. So if you test your source water for phosphates, oftentimes, even if you're on city water, you're going to find phosphates in there. And like my tap here has, I believe, 1,200 phosphates. 1,200 parts per billion. I should clarify that. Parts per billion, not parts per million. If you are registering on parts per million, you've got a lot. All right. We want a thousandth of that. So parts per billion of phosphates. We're talking a very, very small amount. You don't need a lot of phosphates to have a lot of problems. So out of the tap, there are phosphates. Joe, why is that happening? Why are there phosphates in my drinking water?
Well, it's really because they're using it to buffer all those old water systems that are out there, to clean those old water systems, to help the Flint, Michigans from happening again, so that you're not ruining those water systems with the chemistry that's in the water. So it helps.
Well, I would go a step further. Phosphoric and phosphonic acids are sequestering agents. You can buy them in the swimming pool business. We don't make one. Our chelating agent has no phosphates in it, but almost everything, and it's not a knock, it's a great product, but it is phosphate based. The drinking water systems often put these products in your drinking water, and the reason they do that is because they bind to metals and minerals like calcium and iron and lead and anything else. Well, that allows those metals to get filtered out, and it protects us from heavy metal poisoning. That's a good thing. It protects those old pipes from being corroded. It protects those old pipes from being scaled up so that, the inside diameter gets smaller and smaller. It prevents a lot of those problems. And depending on what the system needs, sometimes they want a little bit of scale, but then they want to maintain it without it growing, right? So it's really down to a science. And if you think the pool business has chemistry figured out, if it's any indication, if we are leading in chemistry, and you could see our technical proficiency here on this podcast, I think drinking water knows a lot more than we do. They've really dialed it in. The good news is phosphates are not unhealthy at all. I mean, they're actually very healthy for you. They're great for your lawn. They're great for your dog. They're great for us. So it's good that they're in our tap water. There's just this one application that phosphates are a real pain in the neck, and that's swimming pools. So it's good that we have them in our system, but they are constantly being introduced in most cases. Now, they are also naturally in well water, depending on where you live. If you are in an agricultural area, well, what is fertilizer? Fertilizer is loaded with phosphates, and that stuff seeps down into the water column and it gets into your wells. And so the first source of phosphate that we always have to just kind of view as the default is it's probably in your tap water. Okay, so you're constantly introducing it that way. The second is from us or from the environmental factors around it. So either it's on our bodies or it's on the bottom of our feet as we walk on the ground because there's soils, there's grass. Maybe we walk through the grass to get into the pool. Maybe a rainstorm pulls a whole bunch of stuff off of leaves through soil, and maybe some of that runs into the pool, all sorts of stuff like that. Or maybe you have a gardener who sprays with fertilizer or something like that, And some of that gets in the pool loaded with phosphates. So environmental factors also introduce phosphates into the pool.
Another big source of those around golf course communities, they typically will fertilize through the sprinkler system. So if you're anywhere near those sprinklers and the wind's blowing in the right direction, that's a big source of phosphate. So you live in a golf course community, pretty good chance you're getting a little extra dose.
Oh, absolutely. Or in agricultural. I mean, wine country, Napa Valley, phosphates through the roof because they fertilize and they irrigate in such a way. And a lot of times they'll have planes that fly over and fertilize, and that gets in the wind and gets in your pool. Another source, not a main source, but wildfires. We touched on this on the last episode, but if you are in a wildfire prone area and there's a fire going and there's soot and ash and debris in the air, that stuff is loaded with phosphorus, carbon, and nitrogen. It is getting in your pool. If you can smell the fire, I promise you it's getting in your pool, and in very high doses. Again, we don't need a lot of phosphate to cause a lot of problems. Parts per billion here, okay? The third source is through sequestering agents. It's through pool products. And again, this is not a knock on any of our competitors. These products are great. They work very well. They're great for stain removal, stain prevention. They're sequestering agents. You could be trying to deal with a scale problem or a metal problem, but simultaneously introducing phosphates. And then you see, oh my gosh, I have high phosphates. And you put in our PR 10,000 to remove your phosphates. And boom, that sequestering agent is gone, wiped out in the blink of an eye. And it clouds up your pool. And next thing you know, you got a whole bunch of free metals floating around that they get oxidized, Joe, don't they?
They will.
Now, part of our philosophy, as I said at the end of last episode, we are based on a minimalist philosophy, but part of the Orenda program is no chemical conflicts. We don't have any chemical conflicts within our line. That's not fair to you. If you are trying to rule your pool, why on earth would we want to sell you two things that fight each other? It ain't going to happen. Now, Joe, let's pivot. Now let's talk about why phosphates actually matter. We've already mentioned they're important nutrients, right? Algae needs them, they need to eat. But chlorine can't oxidize these things. So how do we get them out of the pool?
Well, the best way to get them out of the pool is to, get them out through filtration. But you have to change them in order to do that. So you have to basically make them a bigger molecule, make them come out of solution so that the filter can pick it up.
Or vacuum. Mm-hmm. Okay, so expand on that. So we have to convert these phosphates. Right now, they're microscopic. I mean, no filter is going to catch these things. What is this process? So we use something to convert it into a bigger molecule. I'm not going to lead you in this conversation, but what does that reaction look like? What should a homeowner expect if they use a phosphate removal to do what you're talking about?
Well, it's going to cloud the pool up. You're going to see it. It's visual. You can tell when there's phosphates there because when you add a phosphate remover, you see a cloud. The higher the phosphate level, the bigger that cloud can get. And, you can expect that it's going to cloud the pool up, depending on the phosphate level, sometimes for a couple of days.
Mm-hmm. And if you don't have phosphates or very little amount of them, you're not going to have much of a cloud. So I prefer, you could have a phosphate test, and that's good, but not all tests read total phosphate. A lot of them only read one type, and you could have several different types. For instance, sequestering agents are polyphosphate, or they're phosphonic acid, depending on what you get. Those are not always going to read immediately on a test kit. PR 10,000 will. It will find it. And so if it's in your water, you take a little capful. I mean, we're talking just drops here. Put it in front of you, drop it in your pool. And if that cloud, Joe, I have to laugh because this is super scientific, right? Look, we're all humans here. This has worked for me. It's worked in the field. If this cloud gets bigger than a basketball in 30 seconds, it's probably worth treating. I've also seen that little tiny capful of PR 10,000 cloud up half the pool. That is a substantial amount of phosphates in your pool. Now, you need more than that to accurately remove them, but the cloud spreads. And we've got some cool time-lapse videos of just how cloudy it goes. But you want to time this properly. You don't want to just nuke somebody's pool with PR 10,000 and have it cloudy for 3 days because you put too much in at one time without telling the homeowner especially, right? Or timing it that if you have a DE filter that you're already scheduling a media change. This stuff will get caught in those filters and it will build pressure and it can actually damage the grids if you have a DE filter. Commercial pools especially, you want to bypass that filter or shut off circulation and let this phosphate remover do its thing, flock everything out to the floor and then vacuum it out. There's a lot of different ways you can do it. And in your situation, if you are not sure, reach out to us. The key here is not necessarily to wipe out all of your phosphates. Certainly not all at once. You want to work your phosphate level down. The research shows that you really just need less than 500 parts per billion. 500 is a manageable number. Now, my tap, again, is about 1,200. So I would have to remove it if I were to fill up a pool with my water, but I don't have to remove it all the time. How much water am I actually losing? As long as I'm not using a phosphate sequestering agent, or I'm not getting flash thunderstorms that are rushing soil into my pool or the gardener or whatever. I don't have a gardener, but you know what I mean. Those kind of things can be manageable. You can maintain low levels of phosphates with maybe once a quarter treatment, or beginning of the season, end of the season. You don't need a lot of phosphate remover. Technically, you don't need phosphate remover if you want to go back to the earlier conversation, because you could just throw a hell of a lot more chlorine at the problem, right, Joe?
You could. Might not be the best solution, but you could.
It's not going to get rid of phosphates, but this is the final point of this episode. The key here is about the growth and reproduction rate versus the killing rate of your sanitizer, in this case, chlorine. Okay? And if you have a secondary system, sanitizers. If the growth and reproduction rate of algae meets or exceeds the killing rate of your chlorine, you're going to have an outbreak. Joe, is there anything else that you want to add?
Yeah, one of the things that you said about the phosphate being inside the cell wall prompted a thought that if you see algae, you have phosphates. They probably won't show up on your test kit at that point because it's inside the cell wall. But if you see algae, you know you have phosphates. So don't be surprised if your test kit says 0 when you've got an active algae growth going.
Yeah, or even a green pool. I've tested a green pool and it got 0. It's like, something tells me that's not accurate. But then, we do the green pool cleanup. It clouds up like you wouldn't believe. And the test said nothing, but exactly what Joe's saying. If chlorine kills the algae, it releases its nutrients inside those cell walls. Now it can be removed. So go ahead and check that procedure out if you want. But again, if you want more information, you can go into the app, go into the articles section, just type in PHO, and everything's going to pop up because it's a search bar. You'll see tons of information on phosphates in there. If you want to see our sources, they are cited within those hyperlinked blogs. And I think that's pretty much all I wanted to add on that. Joe, anything else?
That sums it up for me.
All right. As always, thank you so much for listening. It means the world to us. We will continue to create podcast episodes. And I think, 'tis the season, Joe. Maybe after next episode, we'll do a green pool cleanup episode. Who knows?
I think I like that.
All right. Hopefully I remembered to do that now that I've said it. Take care, everyone. We will see you next episode when we talk about our fourth and final pillar about cyanuric acid. Thank you.
Thank you for listening to Rule Your Pool, a podcast by Orenda Technologies. For more information on what we discussed in this week's episode, check the links in the description or visit www.orendatech.com.
I hope you find this show valuable enough that you tap that subscribe button and share it with your friends. You can also like us on Facebook and social media. And with our help, you'll be able to rule your pool without over-treating it with chemicals and wasting money. I'll see you next episode.